Thank you. Thank you. So welcome everyone to this talk where I'm going to talk about React at scale. And I'm going to share some of our experiences using React and Redux in a large organization where I currently work. So I want to start with a question. So how many knows who this guy is? Hands up. Not too many of you. Maybe guessed a bit more. This is a characteristic. It's a cartoon of a very popular React or famous React guy called Lee Byron. This is what he actually looks like. And he's working at Facebook, working on React and Immutable.js and other products. And he's doing a lot of conference talks. And he's famous for his bow tie, which he always wears when he's doing talks. And the reason I would like to start talking about him is that I was fortunate to go to ReactJS Conf in San Francisco this spring. And at the after party, I had a chance to have a few words with Lee Byron. And I was very anxious to get answers to some questions about how they use React internally. So I asked him if it's true, this rumor that I heard, that they had like tens of thousands of components at Facebook. And he kind of laughed and said, no, it's not true. We have hundreds of thousands of components. So we started talking a little bit about how they manage such a huge amount of components and how they cope with that. And unfortunately, I would have liked much more time with him because he was quite a popular guy at that party, so he was dragged away from me after a few minutes. But that's basically the problem I will be touching in this talk and how we face them in our organization. So first, a little bit about me. My name is Erik Wendel. So that's a German last name, but I'm fully Norwegian. Living in Oslo and working as a consultant for a company called Beck. So we do mostly long-term projects. I've been with my current client for 4 years, helping them. So sometimes it feels like I'm working there, not for Beck. That's the problem of the consultant. And I only work with large-scale JavaScript apps. So I do some backend stuff, but I mostly live in the front-end world. And in addition to that, I work as a practice lead, which is something we've pretty much made up. But that means that I'm in charge of handling how we look at React and JavaScript projects. Really, I lead our web application initiative and make sure we are up to date and maybe possibly quite ahead, hopefully. So I've been working with React for about 2.5 years now, and my current project is handling organization level front-end architecture challenges. I mean, how do we treat front-end code and design on an organization level instead of just looking at it in the scope of our team or our app? Because usually our app works in a bigger whole. So how many of you were here last year at the same conference? Again, not that many. Those of you who were, remember that I was standing on this stage talking about this app where we adopted React into a pretty large existing backbone app to handle a very large amount of complexity in our views. So I went as far as calling the app for the beast, showing you this picture. And today I'm going to tell the story of what happened after that and how we started introducing React into the rest of the organization and all the other apps and teams that we have. So last year's story was about complexity in one app, but this year's story is more about complexity on an organization level. So a few words about the client. It's basically a bank, one of Norway's biggest banks. Seeing Norway is quite small in the international sense, it's quite small, but in Norway it's quite big. So in reality it's 2 organizations. We do banking and insurances, so that's 2 different perspectives. And in total it's maybe 100, 150 developers working on all of these different products that we manage across 20 teams or more. I can't keep track. It's not really that interesting. It's just to say that I think it's quite big. And the past years, we've had these goals of collaborating more on our GUI development instead of just looking at it from our own app's perspective. And also, we want to a larger degree one unified user experience and design. So the situation last year was that I was asked to reevaluate our front-end stack. We had changed the backbone like 5 years before that from JSP and JSF. And we were approaching a new design for our entire organization. So was the time right? Perhaps. We looked at React and Redux like everybody else. And the reason for choosing that's a completely different talk, so I won't touch upon that. But we landed on React and Redux, and the architecture was pretty much many cooperating web apps with a single sign-on solution, so you could jump between all the different solutions, looking like one app, but in reality being a lot of different apps. So I'd like to show you some screens of what we actually make to give you a sense of actually what we're making. So there's a mobile bank, which I talked about last year. It has about 10 million monthly logins, so quite a lot of users. There's the insurance overview page where you can see all your insurances and you can buy new ones or you can report damage and such. There's a specialized page for car insurances, for your cabin in the woods or on the mountains. There's, of course, a specialized site for ordering insurances for your kids or yourself. And this is one of my favorites. It's a health declaration app where you, in order to buy life insurance, you need to specify your health, basically. So if you have a very bad condition, you won't get as good as a deal if you're perfectly fine. So if you say, yes, I had back problems in the past, you get 20 more questions. Like when did you go to the hospital, which hospital, how long, who is your doctor, etc. It's quite a big app. Of course, there's the open pages, trying to encourage people to become a customer. And there's like the main app, which is the online app where you administer all your customer relationship with the bank, really, like all your money, all your accounts, all your cards, all your payments and such. So this is a landing site. So if I hadn't logged in with a stupid test user, you would see some statistics here on how much you spend per day, per month, net in, net out, etc. This is the card administration page. And here you can set a regional block for your cards. So let's say your company credit card with 100,000 euros in the credit limit. You'd want to block that for every region besides the one you live, perhaps. And lastly, a small site for retrieving the PIN card of your credit card. So you just type in your security number on the back of your card and you get the PIN back. So this is just a small selection of the different services and apps that we make. And our solution to this in the past, in terms of handling front-end code, was to have one huge NPM module called the common UI. Like a real monolith. So that had everything you needed in order to create front-end stuff. So at that time, that meant Backbone, jQuery, underscore, lots of other small utility libraries, lots of security stuff, formatters, images, CSS, Backbone views, custom components, you name it. So that meant it didn't work so well. Nobody knew the entire API. It's hard to make changes. There were no tests, no documentation. And the API surface of something like that is just too big, right? It just injects a lot of stuff in your DOM, and you don't really know why, what or why. So we knew we wanted to change to React, and we knew that we didn't want to end up with this huge colossus. And as I guess you all know, React is great at making small and focused components representing parts of your GUI as a function of state. That's basically what React is. So what we wanted to do is to basically just create a lot of components to represent everything that's a visual element in our sketches in the new design as a React component. So let's do the pin retrieval site for as an example. Like the main action button is a good candidate, and maybe the back button and the price list, the input field, the tooltip, which is the question mark thingy above the input field. Maybe group all of those along with the label as an input group to make it really easy to use as a developer. And perhaps also the page heading. So the developer doesn't need to know, is this a H1 or H2 or which CSS class do I want to use? I don't care, it's a page heading. So I'll just import the page heading. So one of the most dreaded components is the drop-down. I mean, everyone who's tried this custom style drop-down has felt that pain. And when you also want to make it responsive and fully accessible for people using screen readers, it gets a bit tough. So I'll do this one as an example. So we decided to make two packages of this one. It's one with the styling and one for the React component. And the main reason for doing that is that being a big organization, not all of the apps could be rewritten. That doesn't make sense to rewrite stuff just for rewriting it. So a lot of apps would still live on in Angular or Backbone or just plain HTML, like the open web pages. So the styling should be accessible without using React. And we're using Nexus as our internal NPM servers to publish the repos without having to publish them to the public NPM. And using such a component is pretty straightforward. You've all done that, I guess. But the most important thing of a component, or at least one of the most important things, is the public API. I mean, how do you use the component? That's what we as developers see every day, and that it needs to be really tight and really solid. And what we saw is that the pull requests that we opened for any new component or a change to a component would have much more fruitful and a better discussion than we did when we did changes to this huge blob. Because the component only does one thing. It's really easy to reason about. It's easy to attack the pull request as a reviewer. You'd want to give feedback because you want to use that component every day. And to make sure everyone saw the pull request, we'd make an integration to the chat system so everyone would get a notification on the front-end channel when a new component pull request was up. And we would document these new packages in a README file, kind of traditionally, like you always would. But then when the responsibility of creating all these packages was distributed among the front-end developers, something happened. Because when they started writing the documentation and the README themselves, instead of just relying on it being inside this huge blob of common UI, people started treating good documentation in a totally different way. They go from a consumer mentality to a maintainer mentality. They don't expect someone else to do it for them anymore and for it just to be there in the big blob of front-end code. They start treating it in a whole other way. So let's fast forward a little bit, and we end up with a lot of packages. This is just a small part of the list of packages we had a couple of months ago. Let's rewind to Lee Byron saying hundreds of thousands of components, right? So this brings with it a couple of problems, the sheer scale of packages. So I'll go through them one at a time. There's 3, according to myself, and we'll discuss the way we solve the problems. So first off, you want to ensure that packages are consistent. When you enter a package and let's say the dropdown, you don't want to have to check the package JSON file to see what's the command to start a dev server or what's the command to build. It should be the same in every single package, and everything should be consistent. And the most important reason for this is that you will have people improving the packages over time, and many of them won't have seen the package beforehand. So you'd want to make their job as easy as possible. If you don't do that, a system like this will most likely fail. So our solution to that was to use the package generator called Joman, just creating a generator for all our packages. So creating a new package is reduced to just typing yo, new component, and voila. And it can also be used to retrofit old components with new stuff once you add more to the generator. So the second problem is to communicate what a package consists of. So what is a details list or an expandable list or a card or whatever? Naming things aren't on our skill set, so the names often turn out quite weird. So it should be really easy to see visually what a component is and what it supports. So of course you could just read the README file, but that gets tiring after a while. So our solution was just to create example files. So every component had an example folder with an example HTML, which actually shows you the real live React component rendered in all its glory. But still, having to clone the repo and run the npm run build just to check out a component is a slow workflow. You can't do that for long. So we took it one step further, using a tool called Gemini to take screenshots of the example files at build times. And this turned out to work really well with the integration with our Git hosting system, which is Stash or Bitbucket by Atlassian. Because then you can enter any of the projects on Stash, and you can see screenshots of how all the components looks. And not just that, you can also see in the pull requests what are the visual diffs between the old screenshot and the new screenshot, making it really easy to see the differences as the version numbers go up on your packages. So there's another subtle, actually not a little bit, huge thing that comes out of this. And this is that you can start putting your designers on the pull requests, because they'll just check out the PNG and see, the new box shadow looks really good, or the other way around. And you suddenly start to get communication between the developers and the designers in a whole new way. And I feel that when designers are really engaged in the pull requests, discussing changes and really communicating with the developers over real code and real components, rather than just staying inside their little sketch file or Photoshop file or whatever, that's a huge win. That was really when I felt that this is really cool. And then over to the third problem. While screenshots are helpful, you really don't want to be looking inside all the repos all the time to find something. You need to make it discoverable. When you as a developer wonder, is this made already? Or have we made something that looks like this? Or do I need to make a new component? That question needs to be answerable within a relatively short amount of time. What you don't want to do is to have people making their own versions of a button or a drop-down or whatever inside their own app, because that code is not available for other teams. And team number 2 who needs that component, so they won't go looking inside all of the other repos. They'll go to the centralized npm repo, right? So you really don't want to go down that road. So there were some designers in the organization who had started making the first version of a design guide. So that was basically just screenshots from Photoshop or output from Photoshop uploaded to some site. And that's good for communicating like the single source of truth of what a component should look like, but it doesn't reflect how the real React component actually looks like. So it was pretty evident that we had to link these two and make the design guide just show the output of the React components. So this is the first version of the style guide, which was hard-coded, not much use, and it had a lot of different stuff. It had the typography that we were supposed to use. It had a lot of colors. This is fine and well for the designers, but as a developer, you want to work at a different abstraction level. So we have all the buttons here as well. Then it starts to get a bit more interesting for us. We have the links to the React repos. You have a hide toggler here to showing the HTML and the CSS classes that you need. Like this. So you can, for a team not using React, you know exactly what you need to do in order to get this design. And it's also communicated that a list that looks something like this should look like this. It's not going to be a little bit bigger or a little bit bluer or whatever. This is what it looks like. So we suddenly had a single source of truth that everyone could see. And the way we implemented this is using the example file. The example HTML from the package itself would be pulled out by the design guide and put up where you just saw. And we did that through the build script on the CI server for each package. So whenever a package has a pull request from a branch into master, this script would be run whenever it was merged. So we would check the should publish function, which would only return true if it's on master. And then it would, of course, publish the package if it's a new version number. And if it's a new version number, it would also initiate a build of the design system, which would then automatically pull the latest version of the package and basically rebuild the updated design guide. So with this system, you are guaranteed that you always have the latest presentation of all your components on the design guide. So basically what we achieve is it's easy to create new components. It's easy to discover existing components, because if that's not easy, you will just have a lot of duplicates all over your code base. And it's easy to update an existing components by just using the example HTML file, just opening a Webpack dev server, doing what development you want, and upping a pull request, adding the designers and other front-end developers to the reviewer list, and letting them do their comments. And basically the whole automatically updated design guide improved the discussion between developers and designers. So it serves as a platform for discussion around all the components and what they should look like and where they should be used. And ultimately, it supports our business goal of ensuring the consistent design throughout all of the different apps. And even though this is kind of a homemade MacGyver solution, I'm sure other people have done this more smartly, it's incredible to just see the effects on the organization when you suddenly have this one place to look for all your front-end components, not only for developers, but also for designers. What exists, how are they used, etc., etc. But of course, as always, there follows a set of challenges. And while I think React Redux is a great way to build large applications, it also represents a new paradigm. It's heavily inspired by functional programming, and at least in our organization, all the people are traditional Java people, back-end people. They love their object orientation, and they're not that familiar with functional programming. So you have to take into account that they also have to learn the frameworks, but also a new way of thinking. And that manifests itself in different ways. One of them is that they always prefer objects. So let's say you want to write like a thin wrapper between your app and local storage. That should work very fine as just a function with some parameters, returning some data from local storage or an error or whatever. But the guys in my team, they say, no, this needs to be an object. Lots of internal state, lots of methods, and it, of course it had no tests. So that takes some learning. And also the notion of pure functions versus impure functions. I think before we started using React and Redux, a lot of people never took that word pure in their mouth when discussing code. But now it's everyday talk. It's like all the pull requests. If something is unnecessarily impure, it's being discussed. And that's a good thing. And lastly, with Redux action names, a lot of people insist on having imperative action names, like fetch this or do that, or respond to this by doing that in their names. Well, Dan Abramov and pretty much everyone else, I guess, thinks that they should be declarative, saying what happened instead of what are we going to do because that happened. So instead of saying fetch product with ID, when someone clicks a button, you should just say that user clicked button X, or order product button clicked. So other to the organization level stuff. When it's everyone's job to update the package or create the package, it's basically no one's job, right? So who's going to take the job of creating a new package that nobody has made yet? That could sometimes be a problem because people aren't used to thinking like that. They're just used to think that all the front-end stuff should just be available for us in some sort of package and someone should do it, not me. And also frequent updates to the core package, which at our place is just the typography and the colors. That cascades into a lot of updates in all of the other packages, which is a tedious job. Of course, that can be automated, but we haven't done that yet. We haven't gotten that far. So another problem is getting designers to work together, because in my experience, a lot of the designers, they usually like to work on just their own part of the app, sending their sketches to the developers, and then that's that. But when I get a sketch and the typography in the sketch doesn't, I can't find that in the design guide, or they have buttons that's not present in the design guide. Either they shouldn't use that button, or the button should be made. And then the design people should discuss that amongst themselves. And that's usually, at least in the beginning, they didn't do that. And it takes some time because they had this meeting like every other week, and that doesn't work. We need to communicate a lot more. And that's my last bullet point, that we need more and more frequent communication. So we basically created more arenas for discussion, like weekly meetings between all front-end devs and all front-end devs and the designers, and just making more Slack channels, basically, and getting to know each other more. That's really important. So some further work is just getting everyone on board with this way of working, because those of us who really love it, but there are still some people in the organization used to the old way. And we thought experimenting with a mono repo like Facebook and Google do. They have all their code in just a single large repo. And that would remove some of the tedious manual tasks for us. And the ideal thing to do would be to dedicate a maintainer team who owns the product, who owns all of the packages, and that owns the design guide. They don't have to do all of the work, but they can oversee it and delegate work to the teams and make sure the managers realize that this is work that needs to be done. We need money to actually do this work. And hopefully design will stabilize. I mean, we got a new design last year, and there's always a new design coming. But it takes some time to reach a level where the frequency of updates is lowering. And that will lower the need for changes, and new components will decrease. So, in an attempt to summarize, front-end work at this scale feels pretty differently. You suddenly have to think about all the other teams and what components look like in other settings, and you always have to take the discussion to a higher level. And that's a bit tedious at times, but it's you get more work done in the long run. And you will need a solid component library. It needs to be easy to find stuff, it needs to be easy to create new packages, it needs to be easy to update packages. And in order to keep this stuff simple, You need to make tools to ensure that the library has high quality. And of course, this doesn't come for free, which is basically the main problem we are facing now. That of course you need a team, you need some money to make sure you have a good product. But I'm pretty confident that that money will be saved in the long run. So that's basically it. Thanks.